Okay, hi, my name is Aivars, and a quick question, who is using Kafka in production?
Prototype.
Okay, so it's maybe 10%. So let's go to the next slide. So please take out your phones and scan this code, or just enter this Slido code. So this is a simple question, what do you think about Kafka? And while you do this, so right now I work for a company called Ebury. So what we are doing is kind of officially it's called cross-border trade. It means that we are doing currency exchange, and then my team specifically is working on cross-border payments through Swift and SEPA credit transfers and so on. So we use Python, FastAPI, Django, Postgres, Kafka, which is the reason I'm here, and then we run it on Kubernetes in AWS. And the reason I'm giving this presentation is because my colleague, Jose, so blame him, he did a presentation internally. It was more than 2 hours, and we brainstormed together to put together some topics to speak about. And so now I'm presenting you a shorter version of those topics. So if you do not like my presentation, then blame Jose. So let's go further. So since a lot of you haven't used Kafka, so I will give you just a quick overview so that we get the right words and terms. So Kafka, like from a developer point of view, so it just stores messages in some topics, and message consists of key and key and value can be whatever. So it can be binary data, it can be a string, it can be a JSON, whatever. And then these messages are stored in topics. So what's important about topics is that topics consist of several partitions. So one or more partitions. Partitions are numbered, starting with 0. And the property is that each partition within the topic is read sequentially. So at first, do we have a dot? Yeah, so at first, the first message is consumed, then the second, then the third, and it can be consumed in random order from different partitions, but the main idea is that each partition is processed sequentially. So next, a producer is some kind of application that sends messages to the topic, and there can be any number of producers as much as you want, and they can send those messages to whatever topics. However, on the consumer side, there is kind of old-style consumers, but now mostly all consumers are grouped into like consumer groups, which consist of one or more consumer, like physical processes that consume the messages. And the kind of property is that this consumer group has this kind of load balancing in choosing these partitions. So if we have consumer group with one single process, then in this case, it gets messages from all 3 partitions. If we have 2 consumer processes, then it gets messages so one process from single partition and then one process from 2 partitions. Once we scale up and we have 3 consumers, then each consumer consumes from a single partition. And if we add another consumer, it no longer gets a partition, so it's basically running in idle. And so this is kind of one of the Kafka properties of Kafka, is that when you define a topic, you have to calculate or predict how many partitions you need, because you have to correlate that with the number of consumers you will need to process those messages. So this is kind of backwards thinking. Instead of scaling up consumers as much as you want, you have to predict that number when you create the topic. And you can increase the number of partitions later, but it's a hassle, so typically it's not happening. And then, of course, kind of the best part of Kafka is that there can be multiple consumer groups consuming the same topic. So one can send the data to accounting, one can send to CRM. So different consumer groups for different purposes, and they all work independently. However, they all receive the same messages. So each message will be consumed by each consumer group. So that's it about Kafka. So Kafka usage at Ebury. First, we are using Amazon managed Kafka, so it's MSK. So what I forgot to tell you, the same Jose counted that our team has touched around 10 services that are using Kafka for one reason or another. We are owners of most of those services, and right now in this sprint we are deploying 3 new services that use Kafka, so we have quite some experience. Inside Ebury we have custom libraries to make the development of consumers and producers a bit more easier. So we have standardized configuration parameters, we have some logging, tracing, encoding, decoding of these keys and values. We also put the liveness probes for Kubernetes inside there, and we do some standardized error handling. And we also, because at the moment we started using it, we didn't have KSQL, so we have our own library that does aggregations for multiple topics. So it gets a message from one topic, and then it waits for related message from another topic, and once those 2 messages meet, then it produces some aggregated events, something like that. And then there are kind of, one more thing about and we run 2 production systems. So one production system is for Ebury as the main company, and then we had 1 copy of the system running for an unrelated company that we now acquired. So, but we still run 2 production systems. So it's multiply everything by 2. So that's the number of services we are running. So there are 3 main kind of event types that our system processes. So here are CDC events, but CDC here stands for change data capture. So it means that we have a database, and we have an application called Debezium and Kafka Connect that goes through the Postgres logs and extracts all change data and then publishes that as events to Kafka topics. And typically we use that to integrate legacy system and more modern services, and also to move some of the functionality out of those kind of bigger legacy services. And so we are putting that data into query services, where we have a better designed schema that is more friendly for sorting and displaying to the clients. And we also are feeding data lakes. So I do not work on that part. The only thing I know is that most of the messages from topics are put into S3 buckets and then somehow processed from those buckets, and then the data analysis team does the work. So however, since we introduced this CDC, and especially since we launched the first query services, we have this kind of unpleasant situation. So before that, we used to create an obfuscated production database each week and restore the test environment from this obfuscated database. But since we started to consume these CDC events from the database, and then it's consumed by one service, which does some calculations, it produces new domain events, which go to another topic, and then a query service consumes them and stores in its own database. So we no longer can simply just restore this legacy service database, because then we would have to recreate all the Kafka topics, and we would have to recreate the database for service A, service B, and so on. So a lot of services. So for now, we have decided that this is not worth it, but it was a nice feature. I still miss those days when we were able to do this. And so then the bread and butter of Kafka, so what we are doing is that we are publishing domain events, and these are like facts about things that have happened in the system, that we have received a payment, then that we have added a new account, that we send payment to that account, and so on. And typically those domain events have multiple consumers, so each of those events is consumed for multiple purposes. And from the application point of view, this topic is kind of owned by the service that publishes those domain events. And yeah, the way how it works together is called choreography. It means that the service publishes events and it doesn't care what happens after that. if some service is interested in those events, it takes the event, does some processing, publishes another domain event, and so it works by itself. And we have, I think, topic compaction for some of those topics. So instead of keeping like the whole history of changes, it just keeps the latest event with the latest key with the latest value, something like that. And then we have the kind of things that I like the least. So these are kind of, we call it command events. And this is actually, here we are using Kafka as a message queue. So message queue would be better suited for this case, but we use Kafka, so let's stick to it. And here the command events, those are typically sent to a specific service. And this specific service is the single consumer that consumes them. So nothing else consumes those command events. And then typically this topic is kind of owned by the receiving service. So if we have to choose the name of this topic, it typically includes the name of the receiving service. And yeah, so this approach is kind of called orchestration, where we very specifically say that please, the next service that should be executed in the chain should be this one, and that we know that this service will send a reply to another topic, and once we get message there, we know that we will send it to another topic. So it's kind of a bit more organized and easier to trace down. And here we have retention for typically 2 weeks or 4 weeks. So retention is how long the messages are kept in the topic. So after they 1 week old, they are simply deleted. And this is done by Kafka itself. Yes, so I mean, with all technologies, it's the situation. So when they work, then it works, everyone is happy, and you don't have anything to complain about. However, the essence of the technology or a tool shows up when you have failures, when you push the system to the limits, and so on. So this talk mostly is about challenges we had with Kafka and the errors we experienced. So first, I mean, we had failures. I mean, those are errors that happened in production. So it's not like we are playing with something, but this happened in production. So we had failure to publish events. So we have this Debezium and Kafka Connect setup that looks at the changes in the database and then publishes them to Kafka topics, but suddenly it stopped. And so clients and users are doing changes, but they are not reflected in the query service. So we are lagging behind the changes. So kind of it's a huge incident. So what happened? Well, it turned out that the first thing was that we started to capture changes of one specific table. And this table contains the kind of payments uploaded by the client. So it's in a JSON format, so it's transformed and checked and so on, but it kind of keeps all the payments. And it resulted in that the record in the database was too large. And it turns out that the default Kafka message size limit is around 1 megabyte. And we had messages larger than that, so they failed to be sent to Kafka. And so, yeah, that was kind of a bit surprise, but then we had to adjust kind of quite a lot of parameters. So inside Kafka Connect, you first have to allow to override configuration. Then you can set the configuration about the maximum request size, and then inside the MSK itself, you had to increase the maximum message size, and also this replica max fetch max bytes. So that was suggested by AWS support. So after we kind of increased those values, then yeah. So that problem was solved, but it triggered another issue. So I will be talking about it next. So when you start reading about how to handle errors with Kafka, I will have a link at the end of presentation about patterns suggested by Confluence itself. And so the first pattern is to simply, once you can't handle some message, you just stop. And this seems an okay idea for at least some of the events, for example, CDC events, because those are already written to the database. They have happened, and we simply must consume them somehow. And the reason why we can't do that is like we might have some temporary failure, so some database connection got lost or something like that. It might be also a bad event, maybe some memory leak or something like that. And the general approach is that we stop the consumers, we fix the bugs, and so on, and we keep repeating that until we are able to process that. However, in our system, some payments are time critical, so we don't resolve the issue in let's say a couple of hours. It gets delayed, the payment gets delayed to the next day, and that is causing trouble for our customers. So this is not an ideal situation. But yeah, the main question is, what does it mean to stop on error? So how can you stop the application? Any ideas? So okay, yeah, so basically, well, what you can do, you can just sleep in the application, but it means the application is hanging and it's like really not responsive. So you can also crash, like for example, just crash the application. It stops consuming messages and it's all good. But if you are running something like ECS or Kubernetes, then you get into this crash loop where your application is started. It tries to process a message, it crashes, and then it gets restarted by the underlying framework or solution, something like that. And what happens when you are restarting all the time? I showed you how this consumer rebalancing, how like you have a consumer group and Kafka automatically assigns partitions to consumers. So let's say we have a bad message here in partition 1. Oh, sorry. Like that, the wrong button. So this red is a bad message. It gets the consumer number 1, I mean the middle consumer, so I don't know, do you count from 0 or 1 here? But so the consumer gets it, so it crashes. And what happens then is that Kafka does the consumer rebalancing. It assigns this partition with a bad message to another consumer. So it starts to process this message, and it crashes as well. So hopefully, if everything is set up right, so instead of redirecting everything to the single remaining consumer, by this time, the original consumer number 2 has already been restarted, and it starts consuming the messages from those 2 topics. It gets the bad message, and of course, it fails again. So, and this happens all the time. So what's the issue here is that so whenever a new consumer joins or leaves the group, so it means it crashes or it gets started and it joins the group, Kafka does this kind of stop the world rebalancing. So it sends the Kafka brokers send the messages to all consumer processes saying that we will have to, what was the message name? I don't remember, but basically who is alive in the group, and then all active consumers say that, okay, I want to participate in this group. And then Kafka stops all the producers and redistributes partitions among them and then says, okay, let's go. And this causes pauses. So it means that other consumers that are not crashing and they are assigned valid partitions, they will typically slow down. So they won't be able to process messages all the time. So they will get this rebalancing request. So they will stop consuming the messages. Then they will get assigned a new partition. And so it goes. There are some improvements in Kafka. So one of them is like this incremental cooperative rebalance. So the idea is that the consumers are split into smaller subgroups. So it kind of happens easier. You can imagine if we have like 128 partitions that this rebalancing happens for quite a long time. But yeah, this approach splits it into smaller groups. So it's not that bad anymore. Or there's another option you can do, like kind of static group membership, where every consumer knows which exactly partition it wants to consume, but that prohibits you from doing some kind of like dynamic balancing, like starting extra consumer or removing consumer, because each consumer will be able to consume only a specific specific topics. And yeah, and so what are these messages? So the term in Kafka, it's typically poison pills. And we get a lot of poison pills in development environment, typically because we like write simple Python scripts, try to send the message. Sometimes we forget to change the queue name in the updated script, so it sends incorrect message to incorrect topic and things like that. So we get invalid keys, invalid values, invalid key format. So sometimes it's string, sometimes it's JSON. And so basically we have garbage information everywhere. So this is happening in product kind of development all the time, but that doesn't mean that it would happen in production, right? But it actually does. So at the same incident where we fixed the Kafka message size, so it actually, what's interesting, and so they do not put this on a huge banner as soon as you start using Debezium, is that this, in Postgres, if you have a huge record, so for example, huge JSON and it's bigger than 8 kilobytes, typically, then it gets stored in a different place. So it isn't stored in the kind of table itself. The table itself contains only a reference, and data is stored somewhere else. And the thing is, once the record changes, this whole large value is not included into change. And in those cases, kind of Debezium fills this with Debezium unavailable value. And of course, so we have a customer who uploads a large file, and what we receive is this Debezium unavailable value. And of course, it's not a JSON that we expected, so we crash. So when we have to get around this somehow because other customers are uploading files and we must move forward. So how to do that? So again, so this is a kind of typical Kafka device. So you skip the poison pill. So you have to move offset past this poison pill. But in Kafka, you cannot just simply edit a partition offset. So the way you do it is you connect as a consumer and you change the offset value for the partition that you were assigned. And because of this rebalancing, you can just connect and say that I will change the offset on partition 1 because some other consumer might be working with partition 1 and you don't get it. So the solution is to stop all consumers. It means downtime. And of course, there's some rebalancing going on while you stop the consumers. Then you have to advance the consumers for the specific partition. So we try to use this call, which is a graphical web UI for Kafka, or SRE typically does that for using CLI tools. So they just type in the commands, type in the offsets, and do. And then once you have done that, you can start all consumers back up, and so they will move. The offsets have been moved after the poison pill, and so everything kind of works. But it's a downtime. It's even bigger downtime than simply rebalancing the consumers all the time. So, but we can do better than that. So the next error handling patterns that this Confluence document describes, there's the number 2 is dead letter topic, and the number 3 is retry topic. And we have actually a combination of both of those. And it's simply because we do not want to predict which messages can be retried and which cannot be retried. So instead, we just have a retry topic where everything is kind of retried. So how it looks like, the same situation where we have a poison pill. Instead of stopping or crashing on this bad message, what the consumer does, it knows that there's this dead letter topic or retry topic, however you call it. So it puts the message, so this is message number 2, puts it into dead letter topic, and just moves forward it and reads the next message. And then, so in most cases, so in our application, we have another consumer that reads this dead letter topic, and then it crashes. And so if we have to increase some consumers, at least we have to stop this small group instead of stopping several consumers. And yeah, so the best idea feature is that it kind of moves the poison pill out of the way. It can process all other remaining good messages. It's easier to skip over the pill in DLT topic. And yeah, it kind of loses the ordering of message. So another big thing in Kafka is that, oh, it's completely ordered and messages are always processed sequentially. But I mean, in most cases, and for most things, it's like rarely needed. And kind of as every topic can be consumed by multiple consumer groups, then this DLT topic has to be for a specific consumer group, because it might be that the other consumer group is successfully processing the message because it doesn't care about that field. It's doing something completely different, or it's just counting the messages or doing something unrelated. How we do it at Ebury, again, it's like most of the time, it's mostly in the new services we write. So each consumer that we implement, it has 2 configuration parameters. It has more, but 2 main parameters are the input topic and then the DLT topic. And so then, of course, we try to handle some of the errors in the code. If we detect something like really, really stupid, we simply skip the message and raise an error, send an email, send an alert. And sometimes we retry things like, for example, if we are sending message to the outside world and the connection failed with timeout, we do some retries, or some connection timeout, again, do some retries. But once we get to unhandled errors so that we couldn't predict, then if the DLT is defined, then we put the message into DLT and just move forward and process other messages. If the consumer doesn't have the DLT, then it simply sleeps for 10 seconds and then restarts. So sleeping is just so we do not go into this crash loop where it's restarting every couple of seconds, so give it a bit delay. And then, so normal consumers look like this, so that we have input topic, which is the main topic it has to consume. And then we give that DLT topic where to put the bad messages. And then we reuse the same code and exactly the same consumer, but with a slightly different configuration as the DLT consumer. So we put the input topic is the DLT topic, because the actual message is exactly the same as the input in the input topic, and then we simply skip the DLT topic. So if it fails to process message from DLT topic, it will simply retry. So that's it. And yeah, and then there are, of course, it's never easy with Kafka. So what about skipping the poison pill in DLT? So we often do this. However, Kafka has this property that there's no actual consumer group record until you commit the first message. So if you go to a tool like Cole, this web UI, you won't see any consumer because it hasn't committed any message yet. And it's typical for DLT topic that it hasn't received any error yet. And once it receives, so there's no consumer record where you can increase the offset. And so the reason behind that is that actually Kafka stores all committed offsets into a topic itself. So it's kind of eating its own dog food. It is using topics for storing information about topics and consumers. So this is the topic. And then one more interesting, because it's a topic, it gets some other properties that are typical for the topic. It's important here. So the parameter is called retention microseconds. And the default configuration in MSK is that it's 7 days. So, and it's also visible. It's not visible anymore because I don't have a pointer. But it's stored for 7 days. So what happens after 7 days is that the old messages from these consumer offsets are deleted. And so only the 7 days and younger messages are kept. And that leads to, okay, so that leads to the thing that if you have a process that connects to the Kafka topic once a month to consume all messages that came in within the month, it won't have the offsets anymore there. So it will start consuming from the beginning or maybe from the end of the topic, whatever so there are configuration options for consumers. And so how we work around this, so we have a weekly process, and a couple of times it kind of missed those exact 7-day limit and it lost the offsets. So right now some of our consumers are storing the offsets in the database. So once it's run after a week, it first refreshes the offsets from the database, and then it connects to Kafka saying that, okay, give me everything new you have since those offsets. So this is how we work around that. And this is kind of expected behavior. What is quite unexpected behavior, so we discovered this the hard way. So there's this Kafka bug. And so the idea here is, so everything I told before, it applies to consumers that you start every week or every month. Here, even if your consumers are running all the time, as soon as there's rebalancing happening, it will lose offsets if there's no commit for the offset in the last 7 days. And so this typically happens for dead letter topics. So let's say we go for a week without any errors, and the next week starts that it starts processing the same old DLT message because it lost the offset. And the same happens for countries, currencies, and other like tables which do not change frequently. So they do not get any new records, therefore new offsets are not committed. And once 7 days go by, then it gets lost. So this is actually fixed. The problem with that is that we were running 2.7.2 Kafka, like MSK Kafka, and Amazon doesn't offer like a bug fix release for that. Instead, they suggest to migrate to version 3 point something, which is kind of a major release, and there are other things beside this bug being fixed. So we had quite some time we spent testing and seeing how it works. So today we actually, like, I don't know, maybe 4 or 5 hours ago, we managed to upgrade one of our production systems today, Kafka 3.5. So we hope we won't see this bug again, but we have another production system to migrate. So this was quite fun. We actually went through the Kafka source code and found where this is lost. Yeah, and then, I mean, the idea here is that it doesn't have to be a bad event to fail sometimes. And what happened, so it's a bit like related to our internal libraries, but we had an update to the reference data. And this means that we update the reference data, and we had to recalculate large set of other records and produce domain events for all of them. And of course, this takes some time. And the first thing to fail was the Kubernetes live probes, because the liveness probes we updated once we receive a message. And so since we took a longer time long time processing a single message, then we didn't like recreate the liveness probe, and so Kubernetes started to kill our consumers. And of course, like the usual like rebalancing happens, the same message is consumed by another consumer, it does the same, and so it crashes. So what we did, we increased this liveness probe period, so that was kind of obvious solution at the time. But we didn't think about that there's something else. So there's Kafka poll timeout, and it defaults to 5 minutes. And basically, Kafka brokers expect that your consumer asks for new messages at least every 5 minutes. If it doesn't do that within 5 minutes, the Kafka broker assumes that your consumer is dead, and it does the rebalancing, right? Yeah, and so unfortunately, since we had an update for like a major value, and it was like, I would say, I don't remember the number, but it was thousands of records we had to update and send out new domain events with aggregated data. So yeah, it took some time. And the most kind of interesting thing is that during all those 5 minutes, the consumers kept producing new messages to the Kafka saying that, oh, here's the new aggregated domain event, so on. So it was alive, it was communicating with Kafka, but timeout passed, the consumer is dead. Kafka doesn't care. And so what happens then? So situation like this. So we get this green message, which takes some time. So consumer gets the message. It processes it for 5 minutes. And then Kafka drops the kind of consumer connection. So it doesn't drop the connection. It just assumes this consumer is dead. So of course, it does the rebalancing. And then this large message is received by the next consumer. 5 minutes pass. Kafka assumes it's dead. So it gives the message to the remaining consumer. 5 minutes pass. It assumes it's dead. So in the end, so we have all consumers working on something. So no new events are being processed. The logs are accumulating. We see that the kind of consumers are working, but they are lagging behind. And they keep publishing new events to other Kafka topics. And so they are kind of publishing those events 3 times. So it means that some other consumers again get triple the load and they have to consume that. So it was like a bit nightmare. And I guess that's it. So my kind of manager has this saying, so life is such a miracle. So here it's like Kafka is such a miracle. So not to use any other bad words. So here I'll kind of like links I would suggest. So the main link is this Confluent error handling patterns. So I guess I will share the presentation so you can find it. So then there's this one extremely good presentation about how the Kafka works. And the guy explains here how the Kafka is built out of partitions and how these are replicated between brokers. So after that, I got much better understanding of the inner workings, so that typically are not taught, but the guy knows how the Kafka operates. So that was really nice. And because we are using Python, we are using this underneath the Python library. We are using a library written in C++ by Confluent. And I have the pull request there, so it has some movement lately after more than a year. So what it does, I try to set this TCP no delay by default. So by default, it's not set at the moment. And what it means is that your producer won't be able to send more than, let's say, between 20 and 25 messages per second. Just because it's hasn't turned off the Nagel algorithm in the TCP stack, and so the TCP stack basically delays your request for several milliseconds. And so kind of most Kafka tuning articles skip this parameter. So this is like really valuable, but only if you are using this Kafka library underneath. And yeah, there's an article how we found out that this is what affects the performance of producers. And that's it. So now I need to take out your phones again. Scan, there's similar question at the end. And so I promised Jose that I will judge the success of my talk by seeing how I changed your opinion about Kafka in one way or the other. So, and that's it. So if you have any questions, then now is the time.
What kind of tooling you use for topics or consumer performance?
Not directly, nothing for like consumer performance. We typically are monitoring the lag. So it means the position where the consumer is currently and what is the last offset in the topic. And we have this, so these are metrics, they are exported to Prometheus, and then we have Grafana dashboards, and we also have like Prometheus alerts set up that if let's say for this topic, if the lag is more than 5 for several number of minutes, then we raise an alert. Yes?
Can I ask one question? I'm just project manager, so it's just a bit of the business flavor. So
Yes.
So do you have a use case when you actually you fail at some time, you isolate it in a separate topic as you showed this consumer,
Yeah.
but are you able to not stop him or isolate, but try to process all other if are not dependent? I mean, other messages in the topic, is it possible or it's not like being done so in Kafka with the
I didn't understand. Like.
Afterwards.
yes, so it's just, by my understanding, it just stops, yes, and this consumer being like isolated and stop if some of the messages fails, yeah?
Yeah.
But we have like other messages pending in a row for
Yeah.
same consumer. They are not being processed.
No.
They are all skipped. Yes.
They are simply being waited on. So if we have this DLT topic, we copy the message physically to another topic, and we just move forward. So the bad message still stays the same, but we just kind of put it in another topic. So this message needs special attention. And then we have kind of retry processes, and depending on application, sometimes we have logs in Redis saying that we did some shady stuff with this message. We kind of already tried to send it to SFTP server, to some bank, and we do not exactly know what's the outcome. So stop it there. So then we have operations team investigating. So did the bank receive this message? No, it did not. Okay, remove the lock and it will go through. Or sometimes you just look at the message, oh, it's just some. Another common example, so we sometimes receive unexpected messages from the banks, so that are not related to the messages that we send out, but we receive something like, I don't know, so some person did some update by hand, and we receive, but we do not have the matching message for that. So that's okay. So we received it, just move over it, and that's it. Yes.
So you're showing a use case when 3 consumers consume the same message. So do you have some mechanism how to independent consumer? So how you understand that message, like was consumed or shouldn't be consumed twice, for example? Are you able to not to consume message twice in Kafka?
Yeah, well, you have to rely on something else. So let's say you can put, as you start processing the message, you can put a lock in Redis, or you can be smarter in your kind of, for example, database that you see, oh, we already have it. So it's kind of, I would say it's like third-party tooling for that. So use something else. So you can do that with Kafka. Yeah, and one thing that we use with Kafka, so Kafka has this auto-commit. So as soon as you receive a message, it's committed. So we are not using that. So we receive the message, we do the processing, and then we say it's committed.
Any more questions?
Yeah, I would like to ask a question of how much data do you process on a daily basis?
So the number of payments is, okay, so I have worked with companies that have like millions of transactions per day. So here it's like, I would say 10 and more thousand payments per day. But the thing with this company is that there are large portion of the payments is above 1 million. So if it doesn't go through, it's like, it's a million. It's not like micro payment for lemonade in the shop. So it's a kind of huge disaster.
Questions or chocolate time? Chocolate time.